Good day everyone. Today I will be talking on our topic preventive safety from unauthorized IoT devices. Myself Rekha and my colleagues Surashri and Shilpa, we have worked together on this topic. Security experts have demonstrated numerous risks imposed by IoT devices in an organization. Due to widespread adoption of such devices, their diversity, standardization obstacles, we require an intelligent mechanism capable of automatically detecting suspicious IoT devices connected to the networks. Devices not included in a trustworthy whitelist of IoT device types should be detected. In this lightning talk, we are demonstrating detection of rogue devices in IoT network using a distributed ledger. Now let us go through some of the attacks prevalent in the IoT network: DDoS, botnets, and Mirai attacks. A denial of service is an attack in a cyber attack in which perpetrator seeks a machine or network resource to be unavailable, and the users are not able to use these devices. A DDoS or a distributed denial of service is a deliberate attack on a website which mostly consists of overloading a website with traffic to make it unavailable. To acquire the capacity to generate such significant traffic, the attacker must first build a network of infected IoT devices called as botnet. The Mirai attack was one such attack which shook the IoT world. The Mirai bots scan the IPv4 address space for devices that run the telnet and attempt to log in using hard-coded dictionary of IoT credentials. Once successful, the bot sends the victim IP address and the associated credentials to a report server which asynchronously triggers a loader to infect the device. The infected hosts scan for additional victims and accept DDoS commands from the command and control server. Now that we saw the threats in an IoT network, let's focus on prioritize some of the threats which we will be solving. One threat is adding an unauthorized IP address to the network. Another threat which we'll be focusing on is replacing a trusted device with a compromised device physically using a whitelisted IP address. To address these two threats, we are proposing our algorithm which focuses using this solution: IP whitelisting and trust establishment using distributed ledger, token-based communication for whitelisted IP addresses. Algorithm explain. Our algorithm involves these actors: unlisted IP address, gateway server firewall, smart contract, IP address trust verification module, blockchain network, and a distributed ledger. Now, the gateway server acts as the gatekeeper in an IoT network. Our algorithm makes sure that the IoT devices are added to the IP whitelist of the gateway server firewall policy. The gateway server holds a contract account in a public blockchain network. It hosts a smart contract that can talk. The traffic from the IoT devices is directed to a gateway server. It checks for the presence of source IP address in the whitelist. If present, passes the traffic to the IP router or the destination IP of the other devices. If the IP is not present in the whitelist, a smart contract is triggered for adding it to the network. It talks to another smart contract module to evaluate the data packets to verify whether the IP address is trustworthy. Data packets are checked for the tokens. Decision is taken whether the new IP is a trusted or not trusted. The gateway server maintains a whitelist as a string. If a new device is a trusted device, then the transaction is created in the gateway server. The transaction contains a new hash of the string, the IP address, to other peers in the public blockchain. If all other nodes validate it, then the whitelist hash is recalculated and the new block is added to the ledger. Now the original whitelist is updated when the firewall gateway by the smart contract. Now, token-based communication is a solution which we have used to eliminate the threat of new devices being added in an IoT network that sends traffic from a whitelisted IP. If we already have added a whitelist IP and that IP is compromised, then there is a threat to the devices in the IoT network. The device infected with malware can replace a trusted IoT device without being blocked by the gateway firewall. To prevent this, tokens can be used for communication that essentially contain a unique device ID which identifies a trusted device. The easiest way of building a token is to concatenate a series of textual information, use a separator between each of them, and then encrypt it using a one-direction encryption algorithm and transform it into a base 64 string. For example, the token string can be constructed as below using device ID, application ID, user ID, expression, timestamp, time, and some random characters. So using this solution, we can address the problem of a new device being added to the network and also a compromised device in the network. Now let us see some of the conclusion and future works. We can enhance this algorithm for rogue node detection by analyzing the network traffic. We can also enhance this algorithm to provide access control depending on the whitelisted IPs, and to encrypt and decrypt messages using token string, which is generated using a concatenation of many unique IDs to ensure data privacy. These are the references that were used to prepare this lightning talk. Thank you.